Okay, students, let's go ahead and review Chapter 11, Graphing Quadratic Functions. When you remember the definition of function graphically, it must pass the what test? Vertical line test. Remember that. You can do this in Algebra 2 as well. See function notation a lot. Okay, test for the G there. Okay, so that means if I had a parabola like this, it would pass the vertical line test. Anytime I drew a vertical line, it would only touch one time. If I have a circle, it fails in a bunch of places. Okay, if I had a parabola that opened to the left or to the right, it would fail. Okay, and for those that want to know, that would be x equals y squared for this one, and x equals negative y squared for that one. You could have other, linear terms and a constant term added to that. But if it's x equals y squared, it opens left or right. If it's positive y squared, it opens to the right. If it's negative y squared, it opens to the left. So that's how that equation would look for those interested in that. Okay. Remember, it would pass for all lines except the vertical line. For a horizontal line, it's going to pass. And for what kind of line is that one called? It's not diagonal. What do we call any line that's at an angle other than horizontal or vertical? Oblique. Okay, so those would pass. The horizontal and oblique line would pass the vertical line test. Okay, we're done with quadratic cell. Write the equation of the axis of symmetry. Axis of symmetry is what's the line that splits that parabola exactly in half? It always occurs at the vertex. And since our parabolas that we're dealing with open up or down, it's going to be the x coordinate of the vertex, right? Because the vertical line is x equals a number. So whatever that x coordinate is, it's x equals that number is the axis of symmetry. And find the coordinates of the vertex of the graph of each quadratic function. Okay, so the vertex, that point right there, the x coordinate is negative b over 2a. The y coordinate is what I get, whatever that answer is, negative b over 2a, say it was negative 1. Then I plug negative 1 into the function, or the y equation here, and get the y value. So the way you write that is the f of negative b over 2a. That means I am taking this answer, this x answer, plugging it into the function, which means plug it into all the x values over here, and I get a y value. So the f of x is almost the exact same thing as the y. What it does, since it's in function notation, it tells me that when I graph it, it must pass the vertical line test. Y equals, that the rest of it doesn't tell me anything about it. It doesn't tell me it's a function or anything else. Okay, so you'll see this a lot in books all the time. It confuses a lot of kids. All it means is to get the x coordinate, I do negative b over 2a. Take that answer, such as negative 1, and just plug it into the equation and get the y value. Okay, that's what that refers to. All right, so now where does this b and a come from? Well, I have to remember this standard form of quadratic is ax squared plus bx plus c. So there's my b. That's the coefficient of the linear function. Why do I know it's linear? Because the exponent on the variable is 1. This is called the quadratic function because the exponent is 2. This is called a constant function because if I put an x here, it'd be x to the 0. It's just a constant. No, remember, constant is by itself, and that degree is, the degree of that term is 0. Because I had x to 0. Remember, degrees are only on the exponent on the variable, not on the constant, not on the coefficient, only on the variable. All right. So I'm plugging in. There's my A. Now let's change the color here so it stands out more. Go purple. There's my A. My B is the one there, and my C is the constant 2. So I'm doing negative b over 2a. So if we want to write it out, b equals 1, a equals negative 2, and c equals positive 2. So negative b over 2a, fill it in, negative 1 over 2 times negative 2 is negative 4. And that changes to 1/4. So that's the x coordinate of my vertex is 1/4. Okay. Now I got to stick that 1/4 into it. So 1/4 comma f of 1/4. I'm just plug the 1/4 into the function to see what I get. 1/4 squared is 1/16 times negative 2 is negative 1/8 plus 1/4 plus 2. 1/4 is the same thing as 2/8. 2/8 minus 1/8 is 1/8 plus 2 is 2 and 1/8. That's my y coordinate. So you can say 2 and 1/8 or 17/8. If I'm looking to graph it, obviously 2 and 1/8 is going to be more valuable to me. So 1/4 comma 2 and 1/8 is the vertex. That's the coordinates of the vertex. And the axis of symmetry is what the x value is. X equals that number. So that's the axis of symmetry right here. X equals 1/4. Axis of symmetry is always an equation. It's not just a number, so it's going to be x equals. Since ours are going to open up or down, it's always going to be x equals because that's the equation for a vertical line. Okay, write the equation of the axis of symmetry and find the coordinates of the vertex of the graph of each quadratic function. State if the vertex is a maximum or minimum. So if the parabola opens up, obviously, when we're talking about max or minimum, we're always talking about the y value. Talking about the y values. Okay. So is this y value here the lowest y value on the curve or the greatest? It's the lowest, so it's called a minimum. Versus if I have a parabola that opens down, well, this y value right here is the highest one, so that's called a maximum. That's what that refers to. All right, write the equation of the axis of symmetry. Remember, it's negative b over 2a. X equals negative b over 2a. And now fill it in. Well, b is 0. So I have 0 over negative 1/4 is 0. So the axis of symmetry is 0. Okay. Let's go ahead. Axis symmetry right there. X equals 0. And find the coordinates of the vertex. That means x is 0. I plug in 0, I get 0. Okay. And since this is a negative, that tells me it opens down. Since it opens down, it's going to be a what? Maximum. Okay. So you don't even have to graph it. All you have to do is look at that negative, and automatically tells me it's opening down. Since it's negative 1/4, it's going to open wider. The closer it is to 0, the wider the curve is, the closer that coefficient is. And when I say the coefficient, it's the coefficient of the quadratic term only. So if it had something x, something 5x minus 2, I don't even look at those. The shape of the graph is based off of the quadratic term only. So the shape of the graph is y equals negative 1/4 x squared. If I technically wanted to plug in points and use my own brain, I know the vertex there. I want to plug values that will cancel with 4. So I want multiples of 4. I plug in 2 for the x, I get 4, and the 4 cancels with 4, and I get negative 1. So 2, negative 1. From the vertex, go right 2, down 1. Left 2, down 1. If I plug in 4, that's 16, and that's going to be negative 4. So go 4, down 4, left 4, down 4. So that is much more accurate as far as the shape of the graph. Right there. Okay, so we just practice graphing it too. All right, solve quadratic equations by graphing. Okay, so one of the words that it is called is solutions. Solve means get a solution. It's also called the x-intercepts. It's also called the roots. And lastly, it's called zeros. Brain fart there for a second. Zeros. Yes. I believe. Zeros? Or is it zeros? Dang, I just lost. I've had to look that up before. Read zeros like that. All these mean the same thing. Okay? If the exact roots cannot be determined, so they're calling roots in this one. Okay? State the consecutive integers. That's one integer after the other, like between 2 and 3, between -1 and -2, between which the roots are located. So now I'm going to have to graph this. Okay? And find where it crosses the x-axis. Well, this negative x squared tells me it opens down. Remember, the negative says down. Okay, x-coordinate is -b over 2a, which then in this case is 1 over -2. So the x-coordinate is -1/2. So I have an axis of symmetry right here at -1/2. So that means the vertex is somewhere along that. I plug that in, -1/2, and that's going to be 1/4 times the negative is -1/4, plus a half, plus 1. Half minus a fourth is a fourth, plus 1 is 1 1/4. Okay, I'm working on my mental math skills with fractions. Those of you who are weak with it, you have to play in a calculator. So -1/2, comma 1 1/4. Let's change the color. 1 1/4 right there. Now, the shape of the graph is y equals -x squared. So that means I'm going to start at that vertex and use that. If I plug in 1, it gives me -1. -1 gives me -1. 2 gives me -4, and -2 gives me -4. So that's to start at the vertex and go right 1, down 1. Right 1, oops, there's right 1, and then go down 1. Left 1, down 1. Right 2, 1, 2, down 4. 1, 2, 3, 4. Left 2, down 4. Again, it's going to be right across from each other because symmetry. Okay, axis symmetry splits in half. Okay, so it looks like this. So you can see the roots are between -1 and -2 on this one, and the root here is between 0 and 1. Okay, so say between 0 and 1. Okay, and that was between -1 and -2. Now let's practice putting the graph in calculator so you can see exactly what it is. Change the, oh, it is at 100%. Dang, why is this so big? How did this get so big? I thought this was, I don't know why. Okay. All right. So we had, I knew it was negative. So first off, when it's -x squared, you have to use the negative button. You cannot use the minus button or get an error. The only time you use the negative button is for the leading term. After that, if there's negatives in it or minuses, you use the minus sign. So -x squared, there's the square button. Let's go back and look at our equation, minus x plus 1. Minus, and I'm using the minus button, minus x plus 1. Hit enter, hit graph, and there it is. And I can see the zeros between 0 and 1 and -1 and -2, just like I said. Now, I want to find the exact. I hit second trace, which is a calc button, and I want to find where it intersects. If I want to find it intersects, I got to have another equation. Y equals 0. That's the x-axis. So now I'm going to find where it intersects the x-axis, called the x-intercepts roots. Zeros are solutions, as we already wrote down. So second calc, intersect, number 5. Hit enter, enter, enter. It'll jump to the closest one. 0.618 approximately is the first one. Do second calc, number 5 again. enter, enter, and move it closer to the other root, or 0, or solution, or x-intercept, and you get negative 1.62 approximately. Okay, so those would be much closer, as far as how you find it in a graphing calculator. Okay, the roots of a quadratic equation are given. So it means it crosses at -3 and -1. That means the vertex, this is the maximum point, is -2, 1. Okay, right there. That's the maximum. So it's letting me know it's opening down, going right through there like this. Graph-related function, if it has the indicated maximum or minimum point. Okay, so there's what I'm going to graph right there. Okay, let's go to the next one. Solving quadratic equations, y, the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Again, a is 1, b is -7, c is 3. So write out a is 1, b is -7, and c is 3. Now I'll go ahead and erase that so you can see it again. Now I just plug it in. X equals -b is +7 plus or minus the square root of b squared, 49, minus 4a and c all over 2a. 7 plus or minus the square root of 49 minus 12 is 37 over 2. Those are the two exact answers. Square root of 37 doesn't break down more. If it broke down more, I would need to simplify it, but there is no perfect square that goes into 37. So that's the exact, so solve each equation by using quadratic formula. Approximate the irrational roots to the nearest hundredth. Now, irrational number means a number that's written as a radical and is not a perfect square. So that's an irrational number. Notice there's two answers. It says roots. There's always two answers. The degree of the polynomial tells me how many answers there are, or solutions, or x-intercepts, or zeros. So there's two. Notice it's 7 plus the square root of 37 divided by 2, and 7 minus the square root of 37 all divided by 2. So now they want us to plug that in your calculator and get your two answers. 7 plus the square root of 37. Get that answer. Oops. Oh, I'm in, that's why. I'm in the graph mode. I gotta quit out of here. Okay. I'm gonna go parentheses, 7 plus the square root of 37 all divided by 2. And 7, oops, parentheses, 7 minus. The reason I'm doing the parentheses so I can do it all at one time. Parentheses divided by 2. There's my two answers, 6.54 and 0.46. Was it 6.54? I'm trying to remember. 6.54, yes, the nearest hundredth. Okay. And there's our answer. Next one. Exponential functions. Exponential, key word, tells me the variable is in the exponent. In the exponent. That's why it's called exponential. So I rewrote this one so you can see it better. Y equals 2 to the x plus 1. It says graph each function and state the y-intercept. How do I get the y-intercept? We know it's when x equals 0. So I plug in 0 there. I get 2 to the 0 plus 1, which then is just 2 to the first, which equals 2. So 0, 2 is my y-intercept. Now I can go ahead and make an XY t-chart to fill in. Let's say get a couple more, one on the left side, one on the right side. If I plug in -1 for x, -1 plus 1 is 0, 2 to the 0 is 1. So -1, 1. Let's go for 1. If I plug in 1, I get 1 plus 1 is 2, 2 squared is 4. So 1 over 4, 1, 2, 3, 4 right there. The curve is going to go like this. It's got an asymptote, what's called an asymptote at the line y equals 0 or the x-axis, just so you know. It's dashed because that's not part of the equation. An asymptote means a curve comes really close to it but doesn't cross it, or almost always never cross it. You'll get some in calculus that will cross and then come back up to it, but not until you get to calculus level. Okay, now I could have also plugged that in my graphing calculator. Let's practice that. Y equals, let's clear that out, 2 to the, and remember it was x plus 1, parentheses. Oh, I don't have to have the parentheses, I guess. Okay, and I don't need the second one. So I can leave it there and just not highlight it. If you don't highlight it, it won't graph it. And there's my curve right there, as you see. Don't forget, I can use my second table and have a table of values. There's an X, Y, T chart right there, 0, 2, 1, 4, 2, 8. And don't forget, I can hit the up arrow and go backwards. Negative 1, 1, we had all those. We had these three right here. Okay. And as you can see, it's getting closer and closer to 0, 0.5, 0.25, 0.15. It's getting closer and closer to 0. When you get way out here like that, it's basically saying 0. Okay. Last piece down here, solving each equation. So in order to do this, I need to get the same bases here. Right now, they're not the same. One's 9 and one's 3. But they both have 3 in common for a base. I can make this 3 squared to the 3y. And this is 3 cubed. It's 27 to the y plus 2. And then you got to remember from earlier in the year with powers that a power to a power you multiply. So this says 3 to the 6y equals 3, and I have to shoot that 3 through there, and I get 3y plus 6. Now that the bases are the same, I can now set the exponents must be the same in order for it to be equal. So now I have 6y equals 3y plus 6. Subtract the 3y across. Remember, always smaller to the bigger side. And I get 3y equals 6 and y equals 2. There's my solution. So if I was to check that, I could put 3 times 2 is 6, so this is 9 to the 6th equals 27 to the 2 plus 2 is 4. So if I want to check that on my graphing calculator, 9 to the 6th, oops, I gotta go back to the home screen, 9 to the 6th, 27 to the 4th. Same exact answer, so I can check that right there, verify I have it right. Okay, and I believe that does it. Yes, it does. 23 minutes.